Hello everyone, my name is Charles. I'm a backend developer at Pinax, and today I'm going to show you how to boost your sync development using our new Substream Sync library. So first I'm going to start by explaining what's a sync. So a sync is a final destination for blockchain data acquired through substreams. It can route the data it gets anywhere. So for example, we can have database syncs for SQL databases, also NoSQL databases like MongoDB, KV storage syncs for Redis, and any other types of database. It can even send messages to your favorite chat platform like Discord, Telegram, Slack. So for example, you could create a bot that sends messages containing blockchain data on a specific message channel. A sync can also route data to a messaging queue solution like RabbitMQ or Kafka. It could also route data to Prometheus, a logging solution, Elasticsearch, and many more. So as you can now understand, possibilities are endless regarding where a sync can route data. So when it comes to developing your own syncs, you can use any programming language you want. We use mostly TypeScript for our syncs here at Pinax. Most of the time, the syncs are command line applications, and they share similar options and arguments. For example, the run command, the starting and stopping block, the substreams endpoint, and more. But after developing many syncs, we saw that they all share the same boilerplate code, and that's one of the reasons why we made the Substream Sync library. So what's the goal of the Substream Sync library? First, it removes duplicate code between the syncs, comes with a bunch of built-in command line options, provides Prometheus metrics, as a built-in logger, handles cursor automatically. It makes it easy to update and stay consistent between our different syncs during development. And like mentioned in the previous slide, it reduces by a lot the amount of boilerplate code when creating a new sync. It's really easy to use, as I'm going to show you in the demo. And it's a public NPM package that you can now use when creating your own syncs. Now for the demo, I'm going to show you how quickly, by using the Substream Sync library, you can create a sync from scratch in TypeScript that will print blockchain data acquired through substreams directly into a text file. So it will be kind of a text file sync. So first we need to create our node project that we will call Substream Sync Text. So as you can see, I already created a folder called Substream Sync Text. So now I just need to initialize my node project. So I'll run the npm init command. Then we need to install these two npm packages. So the Substream Score package will allow us to consume the substream, and of course, we want to install the Substream Sync library. So now, since we are creating a sync in TypeScript, we also want to add these dev dependencies. So TypeScript, types node, and tsconfig recommended. And now in our package.json file, we will add a build script and a start script that we will use to run our sync. So, and also since the Substream Sync library is using native ESM, we need to specify type module in our package.json file. And since we are using TypeScript for our sync, we need to create a tsconfig.json file. And now we can finally start coding our sync. So we will add an index.ts file. And start with some imports. So I'll explain all the imported objects and functions as we go over the code. And for this example, we also need to do some setup since we want to use the logger provided in the Substream Sync library. So Now we need to initialize a program for the sync and add to the run command the option to specify the path of the text file that our sync will create. So here you can see we are adding the required command line option text file path that will be the path for our text file. Then we will specify the function that will be executed when using our run command. And also one thing worth mentioning is that the Substream Sync library is built on top of the Commander NPM package. So if you are not sure about something related to the CLI, you can go check for answers in the Commander documentation. So here we've specified the function that will be executed for our run command. So here it's a function called action. And here we need to program that parse because we are using Commander. So after this, we need to specify the text file path option in an action options interface that extends from run options to be able to get the option value once in our action function. Now we can add the action function code and go over it. So first we need to use the fetch substream function to download the substream's SPKG, then access our text file path value from our command line option, and then do some setup with the run function. And inside of this substreams.on function is the code that will be executed on every messages coming from the substream. And finally, we will start listening for data from the substream. And now since we are creating a text file sync, we need to write the data we are receiving to the text file, which path is specified in our command line option. So we will add some code inside of the for loop. And of course, we also want to use the logger provided by the Substream Sync library. So here we run JSON stringify on the data coming from the substream. Here we are just logging the text that will be added to the text file. And here finally we are adding the text to the text file using our text file path from our command line option. So with this, we now have our text file sync, and the only thing left to do is test if it's working correctly. If it's the case, we should have a new text file and a cursor file appearing in our folder and a huge amount of logs in our terminal. And of course, first we need to run the build command on our project. So here's the command that we will run to test our sync. We will be using the start script we did earlier in our package.json file and add -- to be able to add some arguments. Then we will be using the run command from our sync and specify with -e the substream's endpoint. So for this example, we will use data coming from the Wax blockchain. Then we need to specify a URL for our substream's package file with the -- manifest option. And this substream is for token transfer on chain. So this represents all token transfer on chain. Next, we need to add the module output we want with the -- module name option. And for this example, we are using graph out. Then we can use our custom option that we added to our sync to specify the path of the text file in which we want the data to go to. So we will name it test.txt. Then -s -1 to tell the sync we want to start processing from the most recent block. And of course, since we want to see those logs, we add -- verbose. So there you go. You can see data coming in from the substream. And if we go check inside of the test.txt file, we can see the blockchain data stored inside of it. So there you go. With less than 50 lines of code, you have a working text file sync. So what's next for the Substream Sync library? First, we want to bring new updates to it like native ESM support and make it BAN and Deno compatible. Also, since the Substreams technology is constantly evolving, we have to keep up with all these changes. And finally, of course, we want to create more syncs using our library and also want to encourage you guys, the community, to use it to create new syncs. So this concludes the Substream Sync library presentation. I hope you saw from the demo how simple it is now to create new syncs. And if you want to see other cool projects like this one, you can look at the Pinax GitHub. So thanks everyone and have a good day. Boost up your sync development with the Substream Sync library.